This is going to be the SPSS demonstration for homework number 3, where we're actually comparing pre-test, post-test assessments for a teenage pregnancy intervention program. Here on the screen you'll see that I actually have my data up, and I'm going to take you through some of the basic processes that I go through whenever I do an analysis like this. And then we'll provide the video for you. This is really a much more simple, straightforward type of evaluation that we're going to be doing here. So the one thing that we do want to begin with is we actually want to begin with some descriptive statistics, like I always tell you to do, so that we can get a picture of what our population is going to look like. We have variables that are measured at the nominal level or the ordinal level and at the interval ratio level. So let's start with the variables that are going to be at a nominal level and take a look at what those are going to look like. So we have gender, we have single family home status, academic ranking could technically, it's going to really be a nominal type level. It could be an ordinal level. Then we actually are going to have frequency of, or we're going to have drug use. We'll have frequency of drug use. We'll have if they're sexually active, highest level of education for the parent, highest level of education for the other parent. And then we're going to put knowledge pre-test over here, knowledge. No, let's not do that. We're just going to look at these variables right now just to get the idea. The mean, the median, the mode are not going to mean anything for these variables. So we just want to get the idea of what our population looks like. So when we look here, we actually know we have 25 participants, and they have answered every question, again with the exception for the highest level of education for their mother and the highest level of education for their father. Now, not all these homes have fathers, so there's going to be some missing data here that is going to be appropriate because fathers are not in the home. We have gender. We have a total of 25 that answered the question for gender. We have 15 who are female. We have 10 who are male. So 60% of those participating are female. In our single parent family status, are they in a single parent family? Almost 50-50. We've got 48% who say yes, we've got 52% who say no. All 25 answered the question. Academic ranking, are they in the lowest 25% of the class, the middle 50% of the class, or the upper 25% of the class? Well, here we actually have our frequencies, and we have that 40% of those in our program are in that middle 50% of the class, but 72% together are going to be in the middle or below. So the majority of those who are participating in our program are in the middle or below the 50% level in terms of their academic ranking. So they're not ones who are achieving a higher level. We asked about drug use. Do you have drug use? And yes, 52% said yes, 48% said no. Of those who said yes, which were 13, we have 10 who responded what they used, but we have 11 who said never. We have 4 that said 1 to 5 times, 6 to 10 times, and more than 10 times. 24% of those who participated and indicated that they did use drugs have do it 10 or more times per week. We asked about sexual activity, and we determined that in the frequencies that 52% are sexually active, 48% say they're not, so it's about 50-50. Highest education level for mother, we have this broke down here. 23 responded. There are 2 in the system that are missing. And the highest level education for father, we actually have 12 that are missing, but those are homes who don't have fathers in it, so this breaks down the level of education for father. The one thing that we can do here also that I will often do is I'm curious to know if for sexual activity who's more active, boys or girls, and just for descriptive purposes. And you can use crosstabs for that. And again, you're not looking at anything other than just learning more about your population. So I'm going to put that over there, and I'm going to put sexual activity over there. And in my cells, I'm going to click my rows column and total, because that gives me my percentages. So here I actually have, for the female, we have 67% of the females indicated that they were sexually active, and of those who indicated they were sexually active, 76% of them were female. So in this particular population, we have more females who are reporting that they're sexually active than we do males. Because within the male population, 33% report that they are sexually active, and within being sexually active, then we have 41.7% who are not. So let me review this again, because this gets a little bit confusing and I have to break it down several times to make sense of it. Are you sexually active? Yes or no? So when we look at female, just within the gender, so all the females, 67% said they were sexually active. When we look at the number who said they were sexually active, everybody who said yes, they were sexually active, of those who said they were sexually active, 77% were female. Okay, for males, we're going to come down here, and we actually have 30% within our male population that said that they were sexually active, and within those who are sexually active, 23% were male. So clearly our females are more sexually active, or reporting to be more sexually active than our males in this case. That's how you can use crosstabs for nominal, ordinal level data to kind of see how they break down and learn more about your population. Whether you need to report this, whether it has merit on your findings is a different story, but this is one way to do that, to look at those different crosstabs. So we could actually even just play with it, and we could say crosstabs, and let's put gender, and let's see who about single parent family home. Let's compare those. So here, do you live in a single parent family home? Yes. Okay. Of the females, all of our females, within our females, 53% of our females live within a single parent family home. Of those who report they live in a single parent family home, 67% are female. So again, more of our females are living in single parent family homes. It's important to look at your percentages and not just your raw numbers, because we have an uneven set of gender here. We have more girls in our population anyway than we do boys. So our percentages actually tell us what's true in terms of that. So here within the male, we actually have, do you live in a single parent family home? Of all the males, 40% reported they lived in a single parent family home. Of everybody who said they lived in a single parent family home, 33% were the males. So that's how you break down these crosstabs and get a sense of these different categories and how they play out. Okay, so the other thing we want to do before we go any farther is we then want to look at our descriptives for our interval ratio level. So we have age, we have our pre-test, we have our post-test, we have our pre-test, we have our post-test, right? Those are all of our scale level. And so here we want the mean and the standard deviation, the minimum and the maximum. That's pretty much what we're looking for here. So here we have in age, we have the minimum age is 13, the maximum is 17. We have a mean of 14.7 years, a standard deviation of 1.33. We have the pretest factor. It looks within range right here. We have the post-test risk factor. 185. This right here tells us clearly that we have an outlier and that we need to go back and we need to look at that. It gives us a mean of 24 and a standard deviation of 34. This is a clear indication there's a problem. You've got a standard deviation larger than your mean. You've got something wrong here, so you're going to have to go back and you're going to have to clean that up. Here we have our pretest protective factor. It's within range. Pretest protective, it's within range. So we have our minimum, our means, and they all look within range with the exception of this pretest this post-test risk factor. So let's go back and let's look at our data. So here's our protest, and here's that one. Now we actually have to decide what to do with that one. And we can do a couple of things here. So when we did our descriptives just then, we saw that in our descriptives, we saw that where this outlier was, we had a mean of 24.36 and a standard deviation of 34. So we could run this again, and one easy way, if you just have a few that are like this, this could be one easy way to do it. Again, there's different roads to get to the end, so some people think some ways are easier, some people think other ways are easier. But what I'm going to show you now is a new trick to be able to isolate cases. And we'll be able to run this again and see what happens when we take this out. So right here, we're going to go to data, our data here at the top, and we're going to say select cases. And when we say select cases, this right here comes up. And we want to do an if condition, and it's an if condition is satisfied. So I'm going to click on if, and I'm going to put over there my post-test risk factor, because that's the one with the outlier. And I'm going to say the outlier was like 185, so I'm going to say select anything that's over 180. Okay, and then I'm going to say continue, and I'm going to hit OK. All of these windows always come up and tells you you have a filter now. You're going to say no. And when you look at this filter right here, you look across, it's selected that one, which means I did that incorrectly. Let me go back, select cases. So I want to select them if they're less than 180. Because I want to keep them active if they're less than 180. So I'm going to put my post-test risk factor over there. Oh, come on. So post-test risk factor, if it's less than 180, I want to keep it in for the analysis. I want to exclude it if it's more than 180 because my outlier was 185. Alright, let's see what I did here. So my post-test risk factor is going to be less than 180. There we go. Now it's going to filter it differently because I put it in correctly this time. And I don't want to save that. Okay, so now when you look at it, it's going to include all of the cases with the exception of the one that has the outlier right there. It excludes the entire case. So I can now go to my descriptive statistics and I can run this again, and it's excluding that case. And when I looked at my post-test risk factor, look, I have a mean of 17.66. I'm more in range, and I have a standard deviation of 8. Now, if I don't want to get rid of that case, if I don't want to exclude it, if I want to keep it, then I can justify plugging in the mean of the 17.67, which would be the mean without the outlier in it. So if I come back here, and I'm going to have to manually do that, so I'm going to plug it in as 17.67. I'm going to go to my data and I'm going to select all cases now. And so now that's included, and it's the mean for the post-test risk factor. So let's see what we get. Let's do our descriptive statistics. We'll do our descriptives again. And look there, I've got a 17.67. So it doesn't, I don't lose the case. It doesn't skew the mean in any way. It didn't change it. We saw what it was without the 185. We saw what it was when we added the mean in there. So it's your choice. What I say is if it makes sense to substitute a mean or a median, depending on what the type of variable it is, to keep those cases in there so that way you don't lose all the other variables. So we're going to keep that case in there. We substituted the mean. Now remember a few weeks back when I told you to always keep your original data in a separate file. Only work on a data file that you're adjusting. Never lose your original data. You saw me go in right there and I manually changed a score in order to do my assessment. There's going to be a variety of times that you change your original data when you compute it differently. If you ever lose that original data file because you've made changes, sometimes you have to go back to it. So always keep an original data separate from what you're working on, and then keep a working data file where you're doing these changes, because some of them get rather complicated, and if you really mess up something, you have to go back and you've still got your original data. That's an example of why you would want to do that. Now that we have actually we found the outlier, and that really was the only obvious problem that we had. So we found the outlier here. So now let's go back, and we have our different statistics that we've done in terms of our descriptives, so we know the situation of our sample population, and I'm going to include that in my write-up. So you'll see that as an example. But what I want to know is the basics things that I want to know is I want to know that difference between the pre-test and the post-test on the risk and the protective factors, right? So I want to compare my means, and I'm going to use a paired samples t-test because I have the same group of individuals, the same group of students who did the pre-test and the post-test. And I want to know pre-test, post-test, pre-test, post-test, and this is the post-test risk factor where I made the change so it doesn't have the outlier in it. Okay, so let me go okay. And then when I look at my findings here, the pre-test risk factor to the post-test risk factor, I have significance here. Pre-test, post-test, and my correlations, I have a significance. This right here can be kind of tricky. This is paired samples correlation. Your paired samples should be highly, highly correlated because you're given the same test, one from pre-test to post-test. If you don't have significance here and if you don't have a high correlation, there's a problem somewhere. So this is just informative. Then we come to the paired samples test. Right here, we have pre-test risk factor to post-test risk factor, right? We have 0.001, so that's a significant change, okay? We have degrees of freedom of 24, and there's our T. Pre-test protective factor to post-test protective factor, we have 0.012. That also is less than 0.05, so that's a significant finding. So we were able to show with our pre and post test that the risk factors came down and the post factors increased. And that's because our pre and post mean, we have the risk factor for the pre-test 19, the post-test risk factor was 17. We would want to see that decrease because a lower level means less risk factor. The pre-test protective factor was 23. The post-test protective factor was 25. So we saw protective factors increase and risk factors decrease. That is our findings of our paired samples t-test. That's the main thing that we're looking for in this particular evaluation because we're trying to evaluate our intervention program. Now we also have knowledge level in determining, right here we have knowledge level pre and knowledge level post. But when we look at those are actually going to be at an ordinal level scale right here. And we have low, to moderate to high. So they're at an ordinal level scale. We have ranked between low, moderate, and high. So we have to run a different test to determine if there is a significant difference between pre and post. What you're going to do in this one, you're actually going to run, I don't remember, I think it's in, I got to remember where it's at. It's in compare the means. I'm sorry, non-parametric test. That's where it's listed here. So in the non-parametric test, you can actually go to the related samples, and in your related samples, you get this right here. And then we're going to go to fields, and in our test fields, we're going to say knowledge pre-test, knowledge post-test. So you select only 2 test fields to run 2 related sample tests. The settings, and what we're going to run is we actually want the Wilcoxon test. So we're going to look at test options. Oops, choose test. Customize test. We want Wilcoxon matched pair signed rank 2 samples. We want Wilcoxon because this is the equivalent of a dependent samples t-test for ordinal level data. We can't run a t-test if we don't have interval ratio level data. So the Wilcoxon is the same thing. Related samples, it's the same thing as dependent samples t-test except for ordinal level data. So when we run that, this is what we're going to get. We actually say right here the median differences between knowledge pretest and knowledge post-test equals 0. We have a significance of 0.01, so we reject the null that there is no difference between the knowledge level at pretest and the knowledge level at post-test. We have shown that knowledge level increases from pretest to post-test. And this is, you get these outputs here, and then this is also going to show you that. So the related samples Wilcoxon signed rank test, we have the positive differences and the negative differences, but we've gone from knowledge post-test and knowledge pre-test. It's got it backwards right here, but we can see that there has been increases. And there's been increases right here, and there's been increases right here. What we're interested in is this one right here, okay? This significance level, and it tells us to reject the null. There is a significant difference between knowledge level before our intervention program and knowledge level after our intervention program. So now as I'm running this, I've determined that there is significant difference pre and post for the measures that we're looking at for our students who've participated in our teenage pregnancy peer review educational system, whatever that is. And you know what? I'm a little bit curious. I wonder if there's a difference between pre and post for girls versus boys. Well, again, we can come back and we can select our cases that we want to run. So we're going to say, let's include, let's get rid of this one, and let's put gender over there, and let's include gender if it equals, we're going to select the gender cases if it equals 1. So you can see here it's excluding everything that has a 2, which is males. So the only ones it will analyze are the ones who are females. This is a temporary way to adjust your data and run some statistics to see some things where you don't have to make permanent changes. So I'm filtering out all the males, and I'm going to go back to my compare means, and I'm going to go back to my paired samples t-test, and they're still in there. And when I run it this time, it's going to just exclude males. It's going to include only the girls. So when I look at the girls, and I come down here, and I look at their pre-test, post-test risk factor, I have significance. When I look at their pre-test, post-test protective factor, I have significance. So there's a significant difference for them in terms of their pre-test, post-test factor. When we look at the mean, Their pretest factor went from, their risk factor went from 21.8 to 19.9, and their protective factor went from 23.3 to 25.6. So it's a small change, but it is significant. Okay, now later on, before the end of the semester, we're going to talk about effect sizes. And this right here is where you get into some of the effect sizes and how do you determine that there's a significant difference when it's such a small difference there. But we'll talk about that later. But I've showed here that for the girls, there is significant improvement on both the risk factor and the protective factor. So you know what, let's see what happens with the boys. So I'm going to say select cases, and I'm going to change my gender, and I'm going to change it to 2 because I want it to just select all the boys. So now it filters out all the girls, and it's only going to run just the boys. So I'm going to go to Analyze, and I'm going to go to Compare My Means. Everything's still in there, except now when it runs it, it's only going to look at the boys. Okay, so here's my paired samples t-test for the boys, and I can show on the risk factors there was a significant change. Okay, but look here on the protective factors, there was no change. It was not significant, so it didn't matter. So while the boys went from 15 down to 14, that's a significant change. There's a meaning behind that perhaps related to our educational program. They went from 23.9 up to 25. So they had a pretty good change right there, but it was not a significant finding, so it most likely happened by chance. So the boys had different outcomes than what the girls did. You know, we can even go into, I'm going to go ahead and say select all cases now. So now everything's open back up. So I'm looking at all my cases. But we could do the same thing with single parent family home. Excuse me. So we can go to select cases. We can say condition. We can say if. We want to get rid of that. So you can just delete it is what you do there. And so let's say single parent family home. And we're going to include it if they say yes, that they live in a single parent family home. So now we've filtered that, and they've included everybody that said no. They've included the 2s. Oh, I'm looking at the wrong one. Single parent family home. Okay, they've excluded everybody that had a 2 because that's a no, and they've only included everybody that has a 1 because that's a yes. We can do the same thing. Compare means. Paired samples t-test, still in there, but it's only going to look at those in single family parent homes, which we have an N of 12. The pre-test risk factor was 19. The post-test risk factor was 17. There was a decrease. There was an increase in protective factors. Was it significant? The risk factors, the reduction in risk factor was significant. The increase in protective factors was not significant for those who live in single parent family homes. So this is just an example. You can actually go into depth and look at all different types of relationships with your data depending upon the questions that you need to answer. So what I wanted to show you there was your descriptives, how to replace an outlier, how to select cases so that you can run different relationships between those variables. But what we were most interested in here was the dependent samples t-test, the pre and the post, to determine if there was a change. Anything else beyond that for the purpose of our question and our evaluation would be informative. Was there a difference for boys and girls? Was there a difference between the factors of if it was single parent family, or if there was drug use, or if they were sexually active? All of those can be looked at here. So it depends on, as the researcher, how in depth you go with this. You'll see my write-up goes with basically what I've covered here. I didn't take the time to go more in depth with it, but it'll give you an example of how to treat this data when you're looking at that. when you're looking at it from your perspective and what you need to run. So hopefully this gave you some additional skills in running some different things, in selecting some cases, and in making some changes when you have an outlier.